And the final video in this topic is on division by radicals. So when an expression involves division by a radical, we can write the expression with an integer denominator which does not contain radicals. This is called rationalising the denominator. So all this means is if we have a fraction, we don't want to write our fraction with a surd in the denominator. And we can eliminate that by doing some simple processes. So this first example, just some nice simple ones, and then we're going to go into some more that are a little bit tricky. 7 over root 3. So to get rid of the root 3 on the denominator, what we're going to do is we're going to multiply this fraction by 1, but I'm going to express the 1 as root 3 on root 3. Once again, I'm just multiplying it by 1, so I'm not changing it, but it means we're going to be able to rationalise our denominator. Now with multiplying fractions, multiply the numerators together and we'll get 7 root 3. Multiply the denominators, which will be root 3 times root 3, which is just 3. And you can see there now we've just got a integer in the denominator. Same idea with b, nothing really different here. This time they'll all be multiplied by root 5 on root 5. And then multiply our numerators, so it'll be 10 root 5 over root 5 times root 5, which is just 5. And then we can simplify the 10 and the 5. 10 divided by 5 is just 2, so our final answer will be 2 root 5. With C, when you have a value in front of the surd on the denominator, you don't have to multiply that, we just have to multiply it by the surd, so it would just be multiplying by root 2 on root 2. Now the process is the same, we'll just have 10 root 2. Now we just have to be careful here, we still got this 2 in the first one, so we're going to have 2 and then multiplied by the root 2 times root 2, which is also 2. We'll have 10 root 2 on 4, which simplifies down to 5 root 2 on 2. Now, if the denominator has the form a plus b root c, we use the radical conjugate to rationalise the denominator. Now, the rational conjugate is a minus b root c. You just change the positive that's in the middle to a negative. That's simple. And I'll show you how that works with this example. 1 over 3 plus 5 root 2, and we're going to express that with an integer denominator. Now we're going to multiply this by the conjugate. We have the 3 plus 5 root 2. So the conjugate of that will be 3 minus 5 root 2. So it'll be 3 minus 5 root 2 over 3 minus 5 root 2. Then from here, we just multiply numerators. So 1 times 3 minus 5 root 2 will just be 3 minus 5 root 2. Now the interesting thing here with the denominator is we end up with a difference of 2 squareds, which makes our simplifying really easy. Our numerator will stay the same, and then our denominator just becomes 3 squared minus 5 root 2 squared. And if we simplify that, we'll have 9 minus 5 squared is 25. Root 2 squared is just 2. So we have 25 times 2. 3 minus 5 root 2 over 9 minus 50. And so our final answer here, 3 minus 5 root 2 over negative 41. Now what you'll find is generally we don't like negatives on denominators either. So we can just do some manipulation here to get rid of that, and it's changing the sign of everything else. So this we can also rewrite as negative 3 plus 5 root 2 on 41. And I think you'll find answers in textbooks will give the answer with a positive integer denominator. Another example, write root 3 over 1 minus root 3 minus 1 minus 2 root 3 over 1 plus root 3 in simplest form. So this is just a little bit of a process. Just be methodical, don't try and skip steps, because that's when you're probably going to make a mistake. We've got the first part here, root 3 over 1 minus root 3. We need to multiply that by the conjugate, so it'll be 1 plus root 3 over 1 plus root 3. And that's minus 1 minus 2 root 3 over 1 plus root 3. Multiply that by its conjugate, which will be 1 minus root 3 over 1 minus root 3. Now we do the conjugate because it will always give us a difference of 2 squareds. That's why we do that. Now we just simplify each section separately and we'll just bring it all together at the end. So this one will be root 3 multiplied by 1 plus root 3, the numerators together, over the denominator, which is a difference of 2 squared, so it'll be 1 squared minus root 3 squared. The second bracket will be 1 minus 2 root 3 multiplied by 1 minus root 3 all over 1 squared minus root 3 squared. Then we can just carry on simplifying. So I'll have root 3 plus 3 over 1 minus 3 minus, expand this with our brackets and we end up with 1 minus root 3 minus 2 root 3 plus 6 all over 1 minus 3. This will then equal root 3 plus 3 over negative 2 minus 7 minus 3 root 3 on minus 2. Then we can combine these together. Our denominators are the same already, which is great. So we'll have root 3 plus 3 minus 7 minus 3 root 3 all over negative 2. Simplify that. Root 3 minus 3 root 3, so root 3 plus 3 root 3. So 4 root 3 plus 3 minus 7, which will be minus 4 on minus 2. Simplify that. We can, negative 2 is common in all terms, so it will give us negative 2 root 3 plus 2. So as I said, just be methodical with these types of questions. And that is the end of radicals and surds.